We'd like to apply encryption to the plaintext now. We know that to encode some data, we'd need a key, a parameter, as well as the plaintext. The encryption result is the ciphertext. To reverse the encryption process, to convert the ciphertext to plaintext, we need to use the same shared key. This explains the name of the working principles of symmetric ciphers. The same key is used for encryption and decryption. What are the strengths of this simple solution? Above all, symmetric algorithms are extremely fast. They can be 1,000 to 10,000 times faster than public key asymmetric ciphers. 10,000 times makes a large difference. It could mean, for example, that to encrypt some text using a symmetric algorithm, you'd need a second, while for an asymmetric algorithm, the same operation would take 5,000 seconds. The difference is obvious. Other than that, symmetric ciphers are based on a simple operation. We've mentioned it earlier. It's the exclusive disjunction, start with symmetric or the exclusive XOR. The following mechanism is the XOR operation has the advantage of being very easy to implement in hardware. Text can be of any arbitrary length. This operation seems custom designed for microprocessors of varying complexity. You can implement devices that use symmetric encryption and decryption. There's a large number of available options. For example, network interface cards. You can purchase NICs that natively support the IPsec protocol. Data encryption and decoding is then delegated from an operating system to this hardware. This solution has its share of disadvantages as well. The first and foremost is setting up a key. You've witnessed this problem when we discussed one-time pad. How can you provide a key to a message recipient to make them decode the message? If the message is intended for the recipient only, the recipient must have their own key. Symmetric algorithms require the use of a huge amount of keys. The key number formula is directly derived from the number of system users. If there are 50 users, you'll need over 1,220 keys. The point is to allow everyone to be able to exchange data with another user in a secure manner. You can't exchange a single piece of information with everyone. Managing that many keys is no trifling matter. This is why symmetric ciphers are not widely used. Moreover, if a potential attacker seizes a key, they will not only be able to decode confidential data, but also freely modify it and encode it back using the same key. This will be unnoticeable and will jeopardize not only the confidentiality, but also the authenticity of transmitted information. How are symmetric ciphers implemented? The concept behind them is very straightforward. Even if an operation does not provide absolute security, if it's repeated enough times, it can at last prove practically secure. This idea is the basis for rounds. Symmetric encryption is performed in rounds. An operation is repeated a specified number of times. The number of rounds depends on a particular algorithm and its configuration. Attacks on symmetric key ciphers usually succeed in breaking an algorithm if 16 rounds of repetition are used. The default round number is, however, 25, giving you a 9-round fallback. The algorithm can be considered secure. It has passed required tests and is widely used. If the principle behind the symmetric key cipher is to work, you can't repeat operations in each round exactly. Using the XOR operation all over won't change the security. You have to introduce an element of randomness in individual rounds. You need different round keys. If you still remember the differentiation between confusion and diffusion, in light of these terms, symmetric ciphers, to be considered more or less secure, need to be the mix of ciphertext, increasing the diffusion as much as possible. They should distribute the plaintext over the ciphertext. The basic division of symmetric key algorithms can be made according to the following principle. Imagine that an algorithm can encrypt a plaintext, an arbitrary string, as a whole. This is how stream ciphers operate.